Did you know that time, space, and gravity are all part of a single invisible fabric that shapes our universe? That's right. This mind-bending idea is at the heart of Einstein's general theory of relativity, one of the greatest scientific breakthroughs of all time. Before Einstein, we believed gravity was just a pulling force, like Isaac Newton described it. According to Newton, every object with mass attracts every other object. That's why apples fall, moons orbit planets, and planets orbit the sun. But Einstein had a completely different view, one that would change science forever. He said gravity isn't really a force. Instead, it's the curving of space and time caused by massive objects. Imagine placing a heavy bowling ball on a stretched rubber sheet. The ball makes a dent, a curve, and smaller marbles rolling nearby spiral around it. That's exactly how Earth orbits the sun. The sun bends the fabric of space-time, and Earth follows that curved path. In this new vision of the universe, space and time are not separate things. They are woven together into a four-dimensional fabric called space-time. Every star, planet, and even you and I distort this fabric a little bit by our mass. And here's the wild part. Time itself bends and stretches near massive objects. Closer to a planet or a black hole, time actually slows down. This isn't science fiction, and it's been proven. In 1971, scientists flew atomic clocks on airplanes and compared them to identical clocks on the ground. The clocks in the sky ticked slightly faster, exactly as Einstein predicted. That means time is not universal, it's relative. What feels like 1 second to you might not be the same second to someone moving differently or standing in a stronger gravitational field. That's why the theory is called relativity, because everything, even time and space, depends on your point of view. Einstein's equations also revealed something even stranger. When enough mass is packed into a small space, space-time curves infinitely, creating a black hole. In a black hole, gravity is so strong that not even light can escape. Near the edge of a black hole, out at the event horizon, time almost stops entirely. If you watched someone fall into a black hole, you'd see them slow down more and more, never quite reaching the center, while from their point of view, time would continue normally. It's one of the strangest consequences of relativity. But this theory doesn't just live in textbooks, it shapes the modern world. Did you know your smartphone's GPS system wouldn't work without Einstein? Satellites orbiting Earth experience slightly weaker gravity and move faster than we do. If engineers ignored relativistic time dilation, GPS would drift by kilometers every single day. So every time you use Google Maps, you're actually using Einstein's math to find your way home. General relativity has also predicted many cosmic phenomena long before we could observe them. It explained how light bends around massive stars, an effect called gravitational lensing. In 1919, during a total solar eclipse, scientists observed starlight bending around the sun, just as Einstein predicted, proving his theory to the world. More recently, in 2015, scientists detected gravitational waves, ripples in space-time itself created by colliding black holes billions of light years away. It was direct proof that space-time isn't just an abstract concept. It's a living, dynamic fabric that can stretch, shake, and ripple through the universe. Einstein's theory didn't just explain gravity, it redefined our understanding of the entire cosmos. It told us that the universe itself could expand, that time had a beginning, and that space could curve back on itself. It connected the very large stars, galaxies, the universe, with the very strange time, light, and gravity. Even today, over 100 years later, scientists are still testing and exploring Einstein's predictions. From the bending of starlight to the warping of time near black holes, every experiment continues to confirm that Einstein was right, at least so far. But there's still a mystery left. General relativity doesn't fully explain what happens at the smallest scales, inside atoms, or at the heart of black holes. For that, we need to unite relativity with quantum mechanics, something physicists are still working on today. If we ever solve that puzzle, we might uncover a theory of everything, the ultimate key to understanding how the entire universe works. So next time you look up at the stars, remember, you're not just seeing dots of light. You're looking into a vast cosmic fabric, curved and stretched by every planet, star, and galaxy. And behind it all stands one man's brilliant idea, that space, time, and gravity are all part of the same cosmic dance. This is the legacy of Albert Einstein's general theory of relativity. the theory that changed the way we see the universe forever.